Okay, we're in section 6.5 of Rogowski's calculus. This is work and energy. We're going to do problem 15 here. Built around 2600 BCE, the Great Pyramid of Giza in Egypt is 146 meters high, and has a square base of side 230 meters. Find the work against gravity required to build the pyramid if the density of the stone is estimated at 2,000 kilograms per cubic meter. So that's what we have. Let's see if we can keep those facts straight. So I took the liberty of drawing my pyramid ahead of time. Let's see, the side of the base is 230. The height is 146. So if that's 0, we'll say y is sort of moving up here from 0 to 146. And then the density of the stone was 2,000. So how do these problems go? Remember, sort of, if it's a work problem, you're thinking work equals force times distance. So if you were going to sort of estimate this, here's how I sort of think about it. You're going to add up a bunch of chunks. How do you estimate it? Well, you'd take a chunk here, and a chunk would just be sort of a rectangular piece like that. There's my rectangular piece. Let's imagine it was delta y high, and we had a side leg S here. So what would be the force on a chunk like this? Well, force is, of course, gravity times mass. And if you were doing mass, that would be like density times the volume. So force, we're going to have gravity. Maybe I'll move down a line here. Gravity, 9.8. Density, they told us in the problem, 2,000. Volume, well, this is going to be S times S. So whatever S is squared times delta Y thickness. Right? This is just the estimate, basically. And then how far did you have to move that? What's the distance this chunk had to be moved? But it would be moved up from the ground to height Y. So distance is going to be Y. Okay, so we need to figure out what this is. Now notice the side length is linear in terms of Y. So what I usually do is I draw a little table. If Y is 0, the side length is 230, right? At height 0, side length is 230. If Y is 146, the side length is 0. So I sort of have a linear function there. So for any given Y, it's a line, right, with y equals mx plus b. Of course, the intercept is 230. And then you just, for each increase in y, you're going to subtract some. Well, I guess I need to subtract 230 1/46ths of y, so that when y gets up to 146, can you see I get 230 minus 230? And I get to 0. So this is the line. That's what I put in right here. Maybe I didn't leave quite enough space, so we'll write it small. 230 minus 230 over 146 y. Okay, so then as you take the limit, right, delta y becomes dy, and those slices start at 0 and end at 146. So 9.8 times 2,000, 19,600. Then here you've got, 230 minus 230 over 146y squared times this y. Okay, so this is the setup. If we can solve that integral, we know the work it took to lift all of the stone into this pyramid at Giza. Okay, so now since I have just polynomial squared, let me go ahead and multiply that polynomial out. I'll pull the 19,600 out in front of my integral, 0 to 146. Let's see, multiplying this out, we'll, probably could do it by hand fairly efficiently, but probably could do it faster with a calculator. So 230 squared is 52,900. Then that's going to be a constant, but then we'll multiply times y. So 52,900y. Then the cross term is going to be 230 times negative 230 divided by 146. But then you're going to get 2 of those, right? Times 2 equals negative 724. Now, if I want 3 digits of accuracy in my final answer, I want to keep at least 4, maybe 5 here. So let me go ahead and just keep 4. This will give me probably 3 decimal digits of accuracy, significant digits of accuracy in my end answer. So this would be a y term here. We multiply times another y to get y squared. Then I need this term squared. So let's take 230 divided by 146 squared. Notice the negatives cancel, so we get positive 2.482 y to the third. It's a y squared times a y dy. Okay, so pretty straightforward to integrate, really. This term gets divided by 2, right? So that's 26,450 y squared. This term gets divided by 3, so 241.6 y to the third. Integrating y to the third gets me y to the fourth, so this gets divided by 4, 0.6205 y to the fourth. And we're going to evaluate that from 0 to 146. Of course, plugging in 0 is going to get us nada, so all I really need to do is I need to plug in 146 squared here, 146 cubed here, 146 to the fourth here. Since these are just, this is just a computation, I'm just going to go ahead and do it on the calculator. So 19,600 times 26,450 times 146 squared minus 241.6 times 146 to the third plus 0.6205 times 146 to the fourth, close, is 1.8. And I'm going to round off to 3 decimal digits of accuracy in my end answer. Notice this E12, that means times 10 to the 12. And the units for this work, because I had meters and my weight was in kilograms, I'm going to have that be in joules. So that's my end answer.